Hey, Summation Formulae, Chapter 6, Lesson number 4. So let's start off with a couple of properties of sigma that are not given in the exam, but you do need to be aware of and know them. If you have two functions, if you're wanting the sum of two functions, and you want the sum of those two functions going from one value to another value, for example, k equals 1 all the way up to n, well, you know really what you're doing is you're subbing in the starting value. In this case it's 1, you're subbing that into the first function, then you'd be adding on and you sub 1 into the second function. You're then wanting the sum going from 1 to, in this case, n, so then you'd sub in the next value, you'd sub in 2 into both functions. Then you sub in 3 and then 4, all the way up to n. Good. If you get rid of these brackets though, what you could do is you could put all the f's together. So you'd have the f of 1 plus the f of 2 and so on, all the way up to f of n. And then what you could do is you could think, right, well, I've got g of 1 plus g of 2 plus g of 3 and so on, all the way up to g of n. So another way of writing that, the sum of two functions, is to just get the sum of the first function, in this case going from k equals 1 all the way up to n, and then get the sum of the second function. And you'd be wanting to add those answers together. So the first property is, if you have two functions, if you have the sum of those two functions, you can split it up. So it is the sum of the first plus the sum of the second. Second property is if you have a constant multiplied by the function, and again you're going to be subbing in a starting value all the way up to a finishing value, in this case k equals 1 all the way up to n. So to work that out, well, you know you'd have a times the f of 1, and then you'd have a times the f of 2, and then you'd have a times the f of 3, and then 4 all the way up to a times f of n. But again, if you think about this, you can simplify it because you could take out a as a common factor. So it'll be a times f of 1 plus f of 2 all the way up to f of n. And really what we're doing is, well, in the brackets here we've got f of 1 plus f of 2 all the way up to f of n. So really that's the sum of this function f going from a starting value all the way up to n. So you could have it as a times by the sum of that function. So the second property is, if you have to work out the sum of a function that's been multiplied by some constant, you can take the constant just outside, work out the sum of the function, and then multiply by that constant, which is a. Those properties were not given, they are not given in the exam, but you do need to know them. You can use both of those properties along with these formulae here to find the sum of a series. The bottom three here are given in the exam, these first two are not. So let me explain. If you have the sum of 1 going from k equals 1 all the way up to n, what I mean by that is if you had a 4 at the top here, it would mean you would have 1, that would be the first term, then 1 again would be the second term, 1 again would be the third term, and 1 again would be the fourth term. So it's really the sum of 1 plus 1 plus 1 plus 1. And really, that's just going to be, well, if it was a 4 at the top, that would just be 4. If you had the sum going from k equals 1 all the way up to 7, that would just mean 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1, just 7 times, and you would just get 7. So if you ever have the sum of just 1 going from k equals 1 all the way up to n, that's just going to be whatever n is. If you change the number slightly though, if you have the sum of 2, let's say you've got the sum of 2 going from k equals 1 all the way up to 3, well that would mean 2, add 2, add 2. You'd have it 3 times. And really, the value of that would be, well, if you have 2, add 2, add 2, that's 6. So it's just 2 times by whatever you have at the top. So that'll be 2n. So if you have just 1, then that's just going to be n. If you have any other number, it's going to be what that number is multiplied by n. These ones here are given in the exam, so if you want the sum of k, that is n bracket n plus 1 over 2. So you'd be replacing k with a different value. Here in this case we're starting with 1, so it'll be 1, add 2, add 3, add 4, all the way up to n. And a quick way of doing that is you've got n bracket n plus 1 over 2. If you want the sum of k squared going from k equals 1 up to n, that is equal to n bracket n plus 1 bracket 2n plus 1 all over 6. And if you have the sum of k cubed going from k equals 1 up to n, that there is n squared times n plus 1 all squared over 4. Some of you may notice as well that this answer here is just the sum of k squared. So if you square the n, you get n squared. Square the n plus 1, you get n plus 1 all squared. Square the 2, you get 4. These ones here at the bottom are given in the exam. You just need to know how to use them. So let's look at a couple of examples. Example 1, evaluate the sum of 2k cubed minus 3k going from k equals 1 up to 10. So the first thing we are thinking for this is, because we have two functions, we can split them up. So we've got the sum of 2k cubed, and then we'd have the sum of 3k. But if you think within that function, we're multiplying by this constant. And remember, if you have a constant, you can take that just outside, just the way it is here. So a constant multiplied by the function, just take the constant outside. So that'll be 2 multiplied by the sum of the k cubed, going from k equals 1 up to 10. We are then taking away, and again, when you've got a constant, you can take that just to the side. So that'll be 3 times the sum of k, going from k equals 1 up to 10. So split it up, and then take any constants outside. After that, well, that's going to be 2 multiplied by, and then the sum of k cubed going from k equals 1 up to 10. Well, k cubed, that's just here that you're looking. You're looking at this one here. And the sum of k cubed going from k equals 1 up to n is just n squared, n plus 1 squared over 4. But here it's not n, it's 10. So we're going to replace n with 10. So we'd have 10 squared multiplied by 10 plus 1, which is 11 squared over 4. We are taking away, we've got 3, just keep that to the side. And the sum of k going from k equals 1 up to 10 would be, well, the sum of k is just here. That's what you're looking at now. But again, we're replacing n with 10, so we replace the n with 10 here. So it'll be 10 multiplied by 10 plus 1, which is 11, over 2. Working that out, that becomes 2 multiplied by 3025. We're taking away 3 times. This works out to be 55. And if you work that out, you get 5,885. Woo! Example 2, evaluate the sum of the series 1 times 4 squared plus 2 times 5 squared plus 3 times 6 squared plus all the way up to 15 times 18 squared. Now for this, what you need to think is, well, you know it's going to be the sum of a series, so you can use sigma to represent it. We are starting with a value of 1 and we're multiplying that by a number 3 above that, and we are squaring whatever that number is. So we're starting with that value, we're multiplying it by 3 above that, squared. So if we start with k, well, we've got k equals 1, so we're starting with a 1. To get to 4, well, we're adding on 3 and we're multiplying, so we're multiplying that by the k plus 3, but it's not just the k plus 3, it's k plus 3 squared. And we're going up 2. Well, we're starting with 1, it's the number that's first, then there's a 2, then there's a 3, and the last part, well, the first number in the brackets is 15, so that's going all the way to 15. To work that out then, just square the brackets first of all, so that's the sum of k multiplied by, if you multiply k plus 3 by k plus 3, you get k squared plus 6k plus 9, and that's still going from k equals 1 up to 15. Multiply each term by k, and that is what you will get. And again, what you need to think is, ooh, it's the sum. It is, it's the sum of your k cubed plus the 6k squared plus 9k. So you can split that up. So you can say that will be the sum of k cubed going from k equals 1 up to 15 plus, and remember, if you have a constant, you can take that to the side. So it'll be 6 multiplied by the sum of k squared, going from k is 1 to 15. Plus 9 times the sum of just k, going from, again, 1 to 15. For the sum of k cubed, well, the sum of k cubed, you're looking at this, but this time we're replacing the n with 15. So that means then we're going to have 15 squared multiplied by 15 plus 1 squared, so that'll be 16 squared over 4. plus then 6 times, and it's the sum of k squared. So for k squared, this is what you're looking at. So it'll be n plus 1, 2n plus 1. So that becomes, if you put the numbers in, well, 15 is n, so n plus 1 is 16, and if you double it and add 1, you get 31, and that'll be all over 6. We are then adding on, it's 9 times, and then the sum of k, well, the sum of k, we're looking just here. We've got n plus 1 over 2. But remember, we're replacing n with 15, so it'll be 15 multiplied by 16 over 2. Work that out, and you end up getting 14,400 plus 6 times 1,240 plus 9 times, and this works out to be 120, giving you an answer of 22,920. Yeah! Example 3. Obtain in terms of n an expression for the sum of 2k squared minus 5 going from k equals 1 all the way up to n, and give your answer as a single fraction in its simplest form. So to do this, well, once again you've got the sum of, and you've got the 2k squared minus 5. So let's split that up. So let's have the sum of 2k squared. But because you've got that constant, what do? Take it to the side. Yes, you take it to the side. So that'll be 2 multiplied by the sum of k squared, going from k is 1 all the way up to n, minus, and then you're just going to have 5. But you'll have 5 n times. So again, imagine if there was a 3 there, well, you'd have a 5, another 5, another 5. You'd have 5 3 times. So that'll just be the sum of the 5s going from k equals 1 all the way up to n. So the 2 is just going to stay as it is. The sum of k squared going from k equals 1 up to n, that is given on your formula sheet. It's just here. Replace n with, well, you don't. You just keep it as n. So you just keep that as it is. So that'll be n plus 1, 2n plus 1 all over 6. It's going to be taken away. Well, if you've got 5n times, remember, that is just going to be the sum of 2 going from 1 up to n is just 2n. So the sum of 5 going from k equals 1 up to n will just be 5n. To work that out then, what could you do? Well, you know, you've got a 2 and you've got a 6 there, so you could simplify that. That'll just become over 3. So 2 sixths is the same as 1/3. We are wanting to express our answer as a single fraction in its simplest form. So to do that, we need 2 fractions. So think just now as 5n is 5n over 1. What we're really wanting to do is to get thirds on the bottom. So with this fraction here, 5n over 1, multiply the top and the bottom, numerator and denominator, by 3. That'll change 5n into 15n over 3. After that, because the denominator is the same, you can put the numerators together. So we've got n plus 1, 2n plus 1, and we'd be taking away 15n. What could you do next with that? Perfect. You can always take out a common factor of n. You've got an n here and another n here. So taking that out then, that'll give us n times. And we've still got n plus 1 multiplied by 2n plus 1, and then we'd be taking away 15. And that'll still be over 3. Multiply the brackets at the top, and that'll give us n times 2n squared plus 3n plus 1 take away 15 over 3. If you simplify that, well, 1 take away 15 is negative 14. It's still over 3. And after that, the final stage is to factorise. Brilliant. So if you factorise 2n squared plus 3n take away 14, you end up getting n minus 2, 2n plus 7. So your answer will be n times n take away 2 times 2n plus 7, and it's still over 3. Just read the question again, give your answer as a single fraction. We've done that, and it's in its simplest form. High five. Example 4, evaluate the sum of k squared going from k equals 25 all the way up to, 45. First of all, you need to think, what does that really mean? What is it we are wanting? Help me out. Brilliant. That really means 25 squared, because we're starting off replacing k with 25, so we'd have 25 squared. And we're going all the way up to 45, so we'd then sub in 26, so it'll be 26 squared. Then we'd sub in 27, then 28, all the way up to 45 that we would sub in. So to work that out, what we're really doing is, well, because it's starting with 25, we're really thinking about all the values before that, going from 1 all the way up to 45, but we're ignoring the first 24. So what we're doing is we're thinking, right, well, if it went from 1 squared all the way up to 45 squared, that's fine, we can easily work that out. But we're missing the 1 squared plus 2 squared plus 3 squared all the way up to 24 squared. So we would have to take that away. The sum of 1 squared plus 2 squared all the way up to 45 squared is just going to be the sum of k squared going from 1 to 45. But again, we're missing the sum going from 1 to 24 of k squared. So you can write it as that. This is the stage where you can now use the formula. So the sum of k squared going from k is 1 up to 45 is just this here. So again, you're thinking, ooh, you're replacing n with 45. So you replace n with 45 in here. So it becomes 45 times 45 add 1 is 46. And then double it and add 1 and you get 91. And it's still over 6. We're going to be subbing in 24 into k squared. So again, it's this one we're using. So we've got 24 multiplied by 1 above that, which will be 25. And then multiply that by whatever 24 doubled, add 1 is. You got it, 49. And then divide by 6. Working that out, if you put that into the calculator, bam, 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 you get 31,395. And if you put this into the calculator, bam, 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 you get 4,900. Working that out, bam, 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 you get 26,495. Yo. Example 5, obtain an expression for the sum of k times k plus 1 times 2k minus 1, going from k equals 1 all the way up to n in terms of n. Again, give your answer as a single algebraic fraction in its simplest form. And part B, hence evaluate the sum of the series 1 times 2 times 1 plus 2 times 3 times 3 plus 3 times 4 times 5 plus 4 times 5 times 7 plus all the way up to 20 times 21 times 39. So to do that, first of all, we are wanting to obtain our expression for the sum of k times k plus 1 times 2k minus 1. First stage is to multiply out the brackets. So multiply the brackets here, we've still got k times, and that multiplies out to be 2k squared plus k minus 1. Multiply each term by k, and that is what you get. Because we have the sum of the 2k cubed, and then the k squared, and then the minus k, we can split that up. So we can think that's the sum of the 2k cubed going from k is equals 1 to n. But remember, because we've got that constant, we can take that just to the side. Then add on, and we've got the sum of the k squared going from k is 1 up to n. And then we're taking away the sum of k going from k equals 1 all the way up to n. So to do that, we would have 2 times, and then the sum of k cubed going from k equals 1 up to n, just use the formula, you can see it just here. That'll be n squared times n plus 1 squared over 4. We're not replacing n with anything because it's just staying as n. So we would have that n squared times n plus 1 squared over 4. We are adding on, the sum of k squared is just here, it's n plus 1, 2n plus 1 over 6. And then we're taking away the sum of k, and the sum of k is n plus 1 over 2. We want to write that as a single algebraic fraction, so we have to take quite a few steps to get down to that. The next thing I would probably do though is to think, well, I've got a 2 here and a 4 here. 2 quarters is the same as 1 half. So let's rewrite that. So that will give us the 1 over 2. After that, well, you've got a 2 in the bottom, you've got 6 in the bottom, you've got a 2. Before you do anything with it, you probably want to get the same denominator. So 6 is the lowest common denominator, so let's change them all into sixths. So to get 6, you would multiply the numerator and denominator here by 3. So that'll give us 3n squared, n plus 1 squared over 6. And to get 6 in the bottom here, you would do the same thing, multiply the numerator and denominator by 3. After that, because we've got so many sixths, add so many sixths, take away so many sixths, let's just deal with the numerators, because the denominator will just stay as a 6. After that stage, what would you do next? Yes, you could always multiply out the brackets and then bring all your terms together, but what's often easier is to take out any common factors. If you look here, you've got a common factor of n, There's an n there, an n there, and an n there. And you've also got the n plus 1 as a common factor as well. So taking out n times n plus 1 as a common factor will leave you with a 3 and another n plus 1 and also an n. It will leave you here with a 2n plus 1 and it will leave you here just with the 3. You can now multiply the brackets inside the curly brackets. Woo! Curly brackets. So you've got n times n plus 1 times the 3n squared plus 3n plus 2n plus 1 take away 3, which will then simplify to 3n squared plus 5n take away 2. And from there, well, if you factorise what is in the brackets, you end up with, we've still got this n times n plus 1, but the brackets become n plus 2, bracket 3n take away 1, and it's still over 6. But again, think back to the question. We had to give our answer as a single algebraic fraction in its simplest form, and we have done that. Yeah! Part B, hence evaluate the sum of the series 1 times 2 times 1 plus 2 times 3 times 3 plus blah 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 all the way up to 20 times 21 times 39. So to do this one, what we are thinking is, well, that answer from part A is going to come into play. You can see here that it's really mirroring this k times k plus 1 times the 2n minus 1. So that is what we had for part A. And you notice here that we are starting with a 1. So k is just going to be 1 to begin with. Just double check this. We've got a k and then a k plus 1 and then double it, take away 1. Well, if we started with 1 and add 1, yeah, that gives us 2. If we double it and take away 1, yes, that gives us 1. If you then moved on to 2, well, if 2 was the value of k, it would be 2 times 2 plus 1 is 3. That's what we've got. And double it, take away 1 is also 3. It works. It works right the way along. The last term, we've got a 20. So if k was 20, you would add on 1, which gives us a 21, and then double it, take away 1 is 39. So we are going to be using this. And the last value of k will be 20. It's always the number that's first in the brackets. The last number that's first is 20, so we've got the sum going from k equals 1 up to 20. We know for this, the sum going from k equals 1 up to n is n plus 1, n plus 2, 3n take away 1, all over 6. But what we're doing is we are replacing the n with 20. So what we do then is we just rewrite this fraction here, but replace n with 20. So we have 20 times 20 plus 1 times 20 plus 2 times 3 times 20, take away 1. Again, it's all over 6. Work that out. Well, it's 20, that's 21, that's 22, that is 59. It's still over 6. Multiply the numbers at the top, divide by 6, and you end up getting 90,860. And that is your answer. Example 6, show that the sum of 4 take away 6r going from r equals 1 all the way up to n is equal to n take away 3n squared. And part B, hence write down a formula for the sum of 4 take away 6r going from r equals 1 up to 2q. And part C, show that the sum of 4 take away 6r going from r equals q plus 1 up to 2q is equal to 2 take away 9q squared. Woo! Lots of different parts. Let's start at the beginning. So the sum of 4 take away 6r going from r equals 1 up to n. That is what we are thinking first of all. But again, because we've really got the sum here, we've got the 4 and we're adding on this negative 6r. So we can split that up. So it'll be sum of just 4 going from r equals 1 all the way up to n. And then we're taking away the sum of the 6r going from r equals 1 all the way up to n. But because we've got this constant, we can take that to the side. So it'll be the sum of 6 times, it'll be 6 times the sum of r going from r equals 1 all the way up to n. The sum of just 4, well, if you've got 4n times, that is just going to be 4n. We are taking away 6 times the sum of r. Well, don't be put off by the r and the k. It's just the exact same thing. We're just changing this letter. The sum of r going from r is 1 all the way up to n will just be this n plus 1 over 2. So that is what we would sub in. After that, we've got a 6. We're dividing it by 2, so it really becomes 3 times the n plus 1. And if you multiply out the brackets, that'll be 4n take away 3n squared take away 3n. That, therefore, will give us an answer of 4n take away 3n is n, and take away 3n squared. That is what we were expecting. Well done. Part B. Hence, write down a formula for the sum of 4 take away 6r going from r equals 1 all the way up to 2q. So to do this, well, we already know from part A that the sum going from r is 1 all the way up to n is equal to n take away 3n squared. So if we're wanting to work out the sum going from 1 all the way up to 2q, well, all we're really doing is we're replacing the n with whatever number we would have at the top. In this case, it's not a number, it's just 2q. So we would sub that in place of n. So we would have 2q take away 3 times 2q squared. 2q squared is 2q times 2q, which is 4q squared. So it's 2q take away 3 times this 4q squared, which will be 2q take away 12q squared. And that's your answer. Part C, show that the sum of 4 take away 6r going from r equals q plus 1 all the way up to 2q is equal to 2 take away 9q squared. So to work this out, well, again, we know how to work out the sum going from 1 all the way up to something. So let's say we had the sum going from r equals 1 all the way up to 2q. Well, we could easily do that. But we'd be missing the terms going from 1 to 2 to 3 all the way up to q. What we're starting with is q plus 1. Imagine if you had numbers in here. Imagine if you had 10 plus 1. Well, that would be 11. So you'd be going from 11 up to some number. So you'd be starting at 11. So you'd be missing the 1 to 10. So whatever q is, well, we're missing that. So we're missing the sum going from 1 to q of the 4 take away 6r. We already know from part A and part B, well, the sum going from r equals 1 up to n is of the 4 take away 6r is n take away 3n squared. And really, we would have to replace n with q in here. And we know the sum going from 1 to 2q, well, we worked that out just in the last example. In the last part, that was 2q take away 12q squared. So really what we've got then, this sum going from 1 to 2q is just the 2q take away 12q squared. That's what we got in part B. And the sum going from 1 all the way up to n is n take away 3n squared. But we don't have n this time, we've got q. So it'll be q take away 3q squared. If you get rid of the brackets, work that out, well, we've got a 2q take away q, which will just give us q. We're taking away the 12q squared, and then we'll be adding on the 3q squared, which will give us take away 9q squared. And that is our answer. Just double check that is the one we are expecting. Woo! It is. Well done. Give these questions a shot looking at the Summation Formulae. It's Unit 2 booklet, pages 17 and 18. Check your answers as you go. Have fun. Enjoy. Hey, hey!